AS level mechanics. Pause the screen, read the question and give it a go by yourself first. And now, the breakdown. So, at time equals 0, a small ball is projected vertically upwards with speed u meters per second, 16.8 meters above the ground. The speed of the ball before hitting the ground is 19 meters per second, and that is instantly, immediately before it hits the ground. Particle moves freely under gravity at 10 meters per second squared. I just want to quickly pause and show you guys something. Here's the mark scheme for the question. It will allow the use of g equals 9.8 to begin with. You will then lose a mark point at B and lose 2 marks at C if you continue to use 9.8. So, the question gives you 10, please use 10. And let's pretend you didn't see the answers to the first question. But let's highlight this and highlight this because those are both part of our equations. Now what I'm going to do is a nice little sketch. So, invisible person, throwing a ball up, ball will obviously come down to hit the ground here. And one thing that's important is we need to choose our motion of travel. If we assume the motion of travel is up, anything that goes down is negative. If we choose our motion of travel is down, anything that goes up is negative. Makes sense, right? I'm going to go positive is up because it makes more sense in my brain, but the answers should not differ. This now means gravity, which is acceleration, goes down, and the speed of the ball going down is also negative. And that is helpful because now when we write SUVAT on the left-hand side to fill in the blanks, S is displacement, not distance, which is only the distance between these two things here, which is 16.8. U is just U, V is now negative 19, A is minus 10, T is still unknown. How do we link these equations? We use the SUVAT formula, V squared equals U squared, minus 2AS, sub everything in. I'm writing 19 squared because a negative number squared is positive, and also stop silly mistakes on the calculator. U squared minus 2 minus 10 and 16.8, that will become positive. So then it'll be 19 squared minus this, U squared will be, put this in the calculator. I've already had it preloaded on my calculator and I can tell you it's 25, therefore U is 5. Lovely, that part is done. Now we want to find T. So, to reread the question, it just says find the value of T, and T is at our first bounds. So, we can pretty much probably use any of the SUVAT equations because, well, look, we have all the information possible. I'm going to use the simplest SUVAT, which is, let's label that A, label this B. V equals U plus A T. So, V is minus 19, U is now 5, which I can actually write in here. And then we've got A is minus 10 and T. So this will give us minus 24 equals minus 10T, T equals 2.4. Do we need units? Probably. Am I going to skip them? Yes, because 1, the question does not actually require them, though it is good practice. So seconds and meters per second, do not forget. The reason why it's good to have it is because if they try to throw in kilometers per hour here, you will instinctively know that's not matching with that, and then you will change it. So do it, it's good practice. Right, C, find T. I'm gonna read the full question out for you guys. Find the time from the instant the ball is projected until the instant the ball is 1.2 meters below A. So, we don't want it to be 16.8, we just want it to be here, 1.2 meters below. So how does that change our SUVAT equations? Well, S is now 1.2. So you can rewrite a new SUVAT, I really don't have space. So we're gonna write 1.2 here. U is still the same, it's still 5. A is still going to be minus 10, and we still want to find T. So we will use the equation S equals UT plus a half AT squared. So 1.2 equals 5t, and then if a is minus 10 times 1/2 is minus 5, t squared, obviously it's a quadratic equation now, so 5t squared minus 5t plus 1.2 equals 0. You can solve this on your calculator as long as you learn how to use it properly, because there is a polynomial function on here. Sorry, what I've realized is this is 1.2 meters below, so it is actually going to be negative. So minus 1.2, and then that will be minus as well. There we go. That's why the diagram's used for, because it's always good to cross-reference what your answer looks like versus the diagram. And then I will put this in my calculator now. And that gives me t equals 1.2 seconds. Done. Now we want to sketch the graph. So we know the ball is we know it's velocity time graph, so let's just stop there. We've got velocity of time. Okay, and we want to label while it crosses. So the ball starts at 5 and it ends up at minus 19. So it's clearly going to be getting slower. And we know that by the time it hits minus 19, we are what time? 2.4. So that's all the information. The initial speed at t equals 0 is 0 and 5, and then it will end when t is 2.4 with minus 19. So label that and label that. And that's done. And that was 2 marks. Hence why it was fairly straightforward, just linear, all good. Now, parts E and D. So let's read this out together. In a refinement of the model of the motion of the ball, the effects of air resistance on the ball is included. And the refined model is now used to find a new value of U. State with a reason how the new value of U would compare with value found in part A using the initial unrefined model. So basically, what would air resistance do to our answer? So let's think about this. We now have something pushing against the ball. So the ball is traveling up, and then we have something pushing it down, meaning it's going to be slower. Imagine if a car was driving at you and you were trying to push it versus you just running. It's obviously going to slow you down. Therefore, air resistance will slow the ball down. Part F. Suggest one further refinement of the model. Well, there's probably loads. Let's see how many we can find. Firstly, this is outdoors. We are going to have wind. Next, we're going to have a particle. We are assuming the ball is weightless. Probably not going to be. We are probably not going to have the ball going directly up and directly down. As you saw earlier when I tried to throw that rubber, wherever it's gone, it did not go straight up or straight down. And as you saw, that was rotating. So you have rotational forces. Honestly, the possibilities to part F of this question are limitless. So make it make sense, find any valid reason, and if you're stuck, just go to the most basic. It is only a 1 mark question. I hope this helped. Let me know what you thought of it, and if you want to do any more mechanics, we can give it a go.